Hello class, Mr. Slusher here. Tomorrow in class we're going to be going over the law of exponents. And so I'd like you to become very familiar with them before we get to class so that we can have a very productive time together. So let's jump right in here. Look at the exponents with zero and negative exponents as well. Okay, for negative exponents, we can see that we're going to follow some very simple rules. One is, say I have a to the negative n power. So the reciprocal of that is a to the n. So let's see what we can do with that in a mathematical equation. So example, a to the negative n, and I'm going to look for its reciprocal, which is 1 over a to the n. See how that works? It works out quite well. Any number to the negative exponent, you simply move it from the numerator to the denominator. If it's in the denominator, you move it to the numerator and take away the negative sign. Okay, let's look at some more examples. Of course, a cannot equal 0 because you can't divide by 0. Okay, let's look at some examples. Okay, we are going to use some powers of negative and 0 exponents. 2 to the negative 2 power. Now, if you remember, we want to get rid of that negative sign in the exponent. So to do that, we're going to simply take the reciprocal, which is 1 over 2 squared. Got rid of the negative. Now we can go ahead and do our operation of 2 squared, which is 4, so we end up with 1/4. Let's take a look at a couple more examples here. Negative 2 to the 0 power. Okay, if you recall, when we first started exponents, we defined anything to the 0 power as being equal to 1, and that's no exception here. That rule still holds. So anything to the 0 power is 1. Okay, so let's take a look at another one. 5 to the negative x. In this case, our exponent is not an integer, it's a variable. So that makes this a exponential function. But we follow the same rules, just the same. We're going to take a reciprocal, 1 over 5 to the x. We got rid of our negative, and that's as far as we can take this one, not knowing what x is. Okay, 0 to the negative 3. We have an exception here. 0 to any power is always 0. First off, you can't take and put 0 in the denominator. It doesn't work. You can't divide by 0 because you're not Chuck Norris. He's the only one that can do that. So there is no reciprocal of that, but it is equal to 0 nonetheless. Okay, let's take a look at some examples here. Let's rewrite with positive exponents. This may look complicated, but it's really quite simple when you break it down and follow the rules that we've just discussed. Okay, we're going to get rid of those negative exponents, and to do that, we're going to write the reciprocal form. So, 2x to the negative 2, y to the negative 3 becomes, again, each individual term with a negative exponent, we write the reciprocal, which is 2 times 1 over x squared times 1 over y cubed. Quite simple. Let's take a look at another one here. Let's see, example number 2. Let's evaluate this expression. 3 to the negative 2 times 3 to the 2. Now there's two different ways we could approach this. The first one is, if you remember right, when you're combining exponential numbers with a similar base, in this case the similar base is 3, you can simply add the exponents. So let's do that first. So 3 to the negative 2 times 3 to the 2, we're going to they have a similar base of 3, so then we can just add the exponents. Take their sum, it equals 0. And if you recall, what's anything to the 0 power? That's right, it's 1. Always will be. Okay, let's take a look at another way to solve this one using the previous rule of taking the reciprocal. Okay, so that 3 to the negative 2 becomes 1 over 3 squared. And again, times 3 squared. So in this case, we have 3 squared over 3 squared, which is, of course, 1. So whichever way you want to approach it, you're going to get the same answer. So whatever you're most comfortable with is fine. Let's take a look at another example here. We've got this expression, 2 to the negative 3, with the whole thing raised to the negative 2 power. Now in this case, when you have an exponent raised to an exponent, we have to follow the simple rule of multiplying the exponents. Now don't confuse that with taking the sum of two similar bases within exponents where we added the exponents. In this case, it's a power raised to a power, so we're going to multiply those exponents. So negative 3 times negative 2 in our exponent position. Negative 3 times negative 2 is, of course, positive 6. And 2 to the 6, that's the same as 2 times 2 times 2 times 2 times 2 times 2, which is about 64. Quite simple. Okay, let's move on to something a little more difficult here. Example 4. Okay, we're going to look at this expression, 5a to the negative 2. Okay, so now I've got a product instead of an integer, which is being raised to the negative 2 power. So in this case, we can use the power of a product rule, which states that to find the power of a product, we simply break it apart and raise each part, to the exponent. In this case, the exponent is negative 2. So break it apart, we have 5 to the negative 2 times a to the negative 2. And then again, get rid of those negative signs by taking the reciprocal of each, and we end up with multiply across the numerators, we get 1, multiply across the denominators, we get 25a squared. 5 squared is 25, a squared is a squared. Okay, one last example, and then I'll turn you loose to do some problems on your own. Okay, we're going to rewrite this expression with positive exponents. First of all, let's take a look and see what we're doing here. In order to move it from the denominator to the numerator, we have to multiply the exponent by negative 1. Okay, so that's what it's going to look like there. And we can take that, and now we have an exponent raised to an exponent, and I'm sure you remember what to do there. Yes, we multiply those exponents. So we have negative 3n times negative 1, which reveals our answer to be d to the 3n. Okay, so again, you can see those negatives canceled out. I had a negative 3n and a negative 1, which resulted in a positive exponent of 3n. Okay, now, here's what I'd like you to do. I've got some examples here for you to do, and before class, I'd like you to go over these and make sure you can do them. If you have any trouble, simply rewind this video and look for an example of one that is real similar to it, and I think you'll be pleasantly surprised that you can find the answer right there. All right, class, we'll see you tomorrow. Bye.